Welcome to today's Tech Talks, still talking about battery development, and today we're joined with Adrian Cooper, who's our Chief Engineer for Development and been with the company 23 years. And we're going to talk today about our battery development process that we've developed here internally at MAHLE, to go through the complete cycle of developing a battery from concept right through to production, and how we can develop batteries for a specific application for our customers. So just talking through the actual whole process, really it starts right at the very start with vehicle simulation.
Yeah.
So what do we do on the vehicle simulation side of things?
Well, I guess this stage of the project is always kind of about understanding the customer requirements and trying to define what the exact requirements are for the battery pack. So that's really trying to understand, what the vehicle attributes are, what do they need in terms of, performance, range, overall power of the system, if they've got specific kind of environmental requirements, durability requirements, or really kind of understanding their use cases and what ultimately it's got to deliver, and then working back from that to define the specification for the pack.
So we can use some of our tools, internally analysis tools, to be able to support that as well.
Yeah, that will be supported by our sort of 1D analysis process, so we can simulate the vehicles, we can simulate it in their different environments, we can look at the power requirements, we can look at how the whole of the powertrain system will impact the efficiency of the system, and then what does that lead to in terms of the capabilities of the battery.
So once we've defined what the actual requirements for the vehicle side is, then we can move on to sort of the cell selection slide, which is the next step in the process, really.
Yeah, exactly. And then it's, once you understand those requirements for the vehicle and you understand what the pack needs to do, we can then look at what's the appropriate technology for that pack, what sort of cells do we know, are we familiar with, have got the right kind of characteristics, what kind of cooling system does it want, effectively define the hardware requirements for the pack that's going to meet those targets, and that's different for each one of these different usage cases. So
we've got a wide range of a database of our cells and different cell formats as well that we can choose from. And
we've got a big database of cylindrical cells, prismatic cells, pouch cells, and they've all got benefits for different applications, different volumes, different use cases. So we can work with the clients to pick the ideal cell, and then again, the ideal sort of thermal management system to get the best out of that cell, given the requirements of the project.
So once we've defined what cell it is and what format it is, then we can move on to start doing the concept, layout and detailed design work in that area. Yeah. So we've got designers internally that can then use
exactly. At that stage, once you understand the cells you're using, we can work on the configuration, obviously, to get the right voltage requirements for the pack. And we can work with the sort of packaging of the particular application to get the best form factor for the pack, the best sort of, I guess, like mass compromise, or really kind of, do the best job of integrating those cells into a pack that meets the overall needs of the customer.
Okay, so once we've designed a basic layout and a concept layout, we can start looking at some of the more simulation techniques. So the first one being electrothermal simulation.
Yeah.
So is that more looking at how the pack will actually work within its own environment? And
Well, there's a number of areas of analysis that we'd want to look at, and we're looking at things like the buzz bar designs, and in terms of the internal resistance of the buzz bars and making sure they're appropriately sized for the pack. We're looking at the thermal distribution within the pack. We want to minimise sort of temperature gradients across the pack during different use cases, so hard driving, hard charging, different sort of climatic conditions, so we can understand how the pack will operate in a range of different situations, and sort of make sure from a theoretical point of view that everything's designed ready to meet the targets it needs.
So is this where we bring in like thermal propagation analysis as well, just to make sure if what happens in an event kind of thing?
Yeah, no, certainly. So things like gas venting simulation we do, and we've done that with sort of cylindrical cells. We're working on that with sort of immersion cooled cells as well. So understanding what's happening with the vent gases during that event and making sure we reduce any chance of sort of propagation to adjacent cells is an important part of that analysis. Yeah.
So once we've done the thermo-analysis, then we can move on to more of the structural analysis. Yeah, okay. So then I guess it was sort of guided by some of the regulations as well, so there are 138.3 regulations. Yeah. Okay, so what kind of structural analysis do we usually do on a pack?
Again, it sort of depends. I mean, typically that might happen at a sort of a module level to start off with, to make sure that we've got the structural integrity we need within the module. And then it really depends on how the pack's configured, whether there's modules built into a pack or whether it's sort of one large sort of structural enclosure as the whole system, and how that enclosure is then mounted into the vehicle. So, you know, again, it comes down to those requirements at the start as to what's the structural requirement of the pack, how's it going to be handled during the sort of, the manufacturing process and things like that, and making sure we've covered off all of the requirements for that pack at the sort of different stages. And I guess it's sort of structural analysis. We can look at sort of vibration analysis as well, and understand the mechanical integrity of the pack.
So at that point then, we've done everything in a virtual world, we've done the design, we've done the analysis. Now it's time to start building packs. So now internally at MAHLE Powertrain, we can build prototypes for people as well before we go into the test environment. So what kind of facilities have we got then for prototyping?
Well, we've got, I guess in terms of the facilities here, we've got test facilities for sort of cells, modules and packs. We can also, and we can assemble the parts we need for those different stages of the process. So we can start off with small rigs for doing some of the validation testing. So things like thermal propagation, we typically do some initial trials on some small rigs before we build up to sort of packs and modules. Some of that development work can be done on dummy cells. So some of the early sort of vibration work we do using dummy cells to make sure we're really confident in the integrity of the system before we move on to doing, say, shaker rig tests with live packs.
Yeah, okay. So,
but yeah, we've got assembly facilities here, and with our facilities over in Germany, we've got the ability to weld the cells as well. So
yeah, I've seen the facilities in Germany. So as well as the test side of things, they've got a lot of safety-contained workbenches that we can actually build modules on, and then we've also got the laser welder and the pick and place machine as well, so we can do everything in a safe environment. It's quite impressive what we're seeing. So we'll leave it at that for the end of part one. We'll come back in 2 weeks' time with part two, where we'll go from testing and validation right through to real world validation.